Explain how the wind produces a force on the waka hurua that has a component in the direction that the waka hurua is traveling. Use the grid below to draw a vector diagram to help your explanation. The vectors for the initial wind velocity VWI, the final wind velocity VWF, and the velocity v of the waka hurua are drawn on the grid to help you. Start your answer by finding the vector for the change in the velocity of the wind. To find the vector of the change in velocity of the wind, we can subtract the initial velocity vector of the wind from the final velocity vector of the wind. The change in velocity of the wind is roughly northwest. This means that the change in momentum, and therefore the force on the wind, must also be roughly northwest. By Newton's third law, the force on the waka must be equal and opposite to the force on the wind. Since the opposite direction of change in wind velocity is not perpendicular to the direction of the waka, it will have a component in the direction of the waka. This means that there's a force on the waka hurua that has a component in the direction that the waka hurua is traveling.